All right, we are back in section 4.4 here, and we just looked at the two different types of concavity, concave up and concave down. We saw the basic shapes of those, and we saw these two main points here. If the second derivative is positive, that leads us to concave up type of shape for the function. F of x is concave up with that positive second derivative. So we have our positive, happy-faced, smiley guy here showing the shape of a concave up function. And then if f double prime of x is negative, we've got a concave down area of our function. So this frowny face guy here is feeling kind of negative, feeling kind of down. So negative second derivative leads us to concave down. And that difference there, positive second derivative, concave up, negative second derivative, concave down. Collectively, those ideas are called the second derivative test. Second derivative test for concavity. Okay, just like we had a first derivative test showing us where the function was increasing and decreasing, we have a second derivative test here for concavity, showing us where a function is concave up and where it's concave down. And now that we know those two different types of concavity, we can talk about what it's called when a function changes concavity. So here, where a graph has a tangent line and changes concavity, that point is called an inflection point. Okay, inflection point, or point of inflection if someone's feeling a little fancy. I think our book calls these points of inflection, but I learned it as inflection point, IP for short. So inflection point or point of inflection, it means the same thing. It's practically the same wording. So what that looks like is where we change from concave up to concave down. So concave up, switching to concave down, or the other way around. You could switch from concave down to concave up. The point where that switch happens is called your inflection point. So what that might look like, let's see. If we start with a concave up type of shape, you'd have one side or the other of your happy face, positive second derivative type of shape here. I'm gonna do a shape kind of like this. Okay, that portion is concave up. And then at some point in here, we are going to transition to a shape that is concave down. Okay, so let's label these real clearly here. Concave up. This is concave down type of shape. And so this point right in the middle where it switches from up to down, that is an inflection point. Okay, now you could have the other type of scenario here. Let's switch things around. Let's say your function had started out concave down. Okay, concave down. I often abbreviate this as CD for concave down. And then we're going to switch to being concave up, CU. So that point right in the middle where it switches, that is an inflection point. All right. And, you know, both of these pictures I've drawn kind of half of the concave up shape, half of the concave down shape. All right, half of the concave down, half of the concave up. You could have more than that, like one more example here, just to give you a variety. If you had something like this type of shape, that has multiple types of concavity and an inflection point here. So this portion of the graph is concave up. Okay, we can kind of see that happy face, smiley type of shape. The second derivative is positive over there. And then over here, the function has switched to being concave down. We see that upside down, frowny type of shape. The second derivative would be negative over there. And so on a picture like this, sometimes you can't tell the exact spot where it changes, but you can get a pretty close idea. I'd say right about here, that looks like where our inflection point is going to be. Okay, so as you might guess, inflection points are going to be kind of important because they tell you an important characteristic of the graph, switching different types of concavity. So we'd like to know how to locate those. And how we do that is very similar to the critical points of the first derivative. We are going to check where f double prime of x equals 0. Okay, many, but not all of these. So many of these are inflection points. But sometimes in some situations, you'll have concave up on one side of that point where f double prime of x equals 0. And then on the other side, it might still be concave up. Okay, so that would not be an inflection point in that case. So many of these are inflection points, but not all of them. Now, also, when we do our testing of a function, we're going to do something very similar to our first derivative test. We're going to set up some number lines. We're going to put points on those. We're going to test the second derivative in certain intervals. So for that testing, you are also going to want to know where f double prime of x is undefined. So make sure you also ask yourself that. Where is f double prime of x undefined? Okay, so we'll need all of these for testing our second derivative. Places where the second derivative equals 0 could give you inflection points, but that's a big part of the testing there, seeing if they really are inflection points or not. Okay, so that is the idea behind inflection points, or points of inflection.